You heard me talking yesterday. Some differential equations we can solve, some we cannot. The ones we have solved so far have looked like this. Y prime equals 3x. And then we integrated to get y equals 3 halves x squared plus c. All right? Now, you noticed yesterday you had some x's and y's in your slopes. Did you notice that? Okay. That is when things get a little bit more complicated because I could not integrate this right side if it was 3xy or 3x divided by y. Okay? So, if we have a function in terms of x and a function in terms of y, either multiplied or divided on the right side, then it's called a separable differential equations, and we have to separate our variables. Now, when they are not basic, like the one I wrote up here, they are not separable, then that's when we only really have the slope fields. Okay? So, here are your steps. Okay? We are basically going to integrate both sides at the same time. So in order to do that, we want all of our y's and dy on one side, and any x's and dx on the other side. So we can integrate with respect to y on the left side, we can integrate with respect to x on the right side. After we integrate both sides, all right, we're going to have to clean it up so that we actually have like a y equals equation. All right. Now, sometimes we are going to be asked for the general equation. Sometimes we will be given an initial condition. If we are given an initial condition, the same steps go. This time we just have to solve for c using our initial condition and then rewrite our equation again. Okay, I will tell you right now, we are going to integrate quite a bit with like a 1 over x or 1 over y. So the natural log is going to come into play more often than it has before. Okay, which means we're going to have to remember our properties of logarithms and exponentials a little bit. The general solution is y equals blah, blah, blah plus c. Does that answer your question? Okay. And so when we can solve for c, we can actually write it as a c. All right. So I have 3 examples, which would take us, up until you might have a few minutes to get your homework started. And it is a book assignment book today, and tomorrow I just have it written in on the board. Sorry. Are we ready? here we go. dy dx is y over 1 plus x. I see that x and y are both a part of my derivative. Okay, not going to work out so well. So I need to separate my variables. First of all, I want y's on one side and x's on the other. So how do I get dx over to the other side? How do I get y to the other side? Okay, divide by 1. I don't know. So we have 1 over y times dy equals 1 over 1 plus x times dx. Okay. So from here, we are going to integrate both sides. On the left side, what do we have? Natural log of what? Okay. Plus c, right? And what do we have on the right side? Plus c. Now, these constants could be anything. So I'm going to subtract this constant over to here, and we still have a constant. We really only need one on one side. Is everyone okay with why that is? Okay. We don't know what they represent, but I know if I take a constant and subtract a different constant, we still have a constant. So we're just going to write one. Okay? Shoot, how do we get a y equals out of this? Okay. Now, both sides have a natural log. So instead of just changing forms, I can exponentiate each side. Okay. We technically have plus c's on both sides, right? Yeah. But I know whatever this constant is, if I subtract this constant over, I still have a constant. So I'm just going to write it as this. Make things simple. Okay? This is allowed, right? Sure. Okay. What happens when we have e to the natural log? What happens when we have, well, hold on. Before I do this, what does it mean when we add with an exponent? We're multiplying with same bases, right? So I'm going to do this. Okay? And now we can say this. Okay? What kind of number is e? And it's being raised to a constant. So what is it really? A constant. Okay? Now, our constant is going to affect whether we have positives or negatives. So we can just say y equals our constant times 1 plus x. We don't have to worry about the absolute values because our c is going to be what's affecting the positive or negative. This step from here to here will pop up quite a bit when we are solving this. Okay, with the e to the c. Okay, is everyone okay with why we took e to the c and made it just c? Still a constant. A constant is standing for a specific value. Okay, so if we take c and add it to c, we still get a constant. Okay, thank you. E to the c, still a constant. Alright. Try one that's a little bit more simple, but we have initial condition. So the first thing we need to do is separate our variables. What will we have on the left side? Y dy, and on the right side? So when we integrate, we have technically we have plus c's on both sides. I'm just going to write it on one. Right? Now we want to solve for y, correct? So what can we do? Multiply by 2. So we have y squared equals negative x squared plus, just write it as c. A constant times a constant is still a constant. Okay? Now what? Now, our initial condition is the coordinate 4, 3. So when x is 4, y is 3. Okay? Now, am I going to choose the positive or the negative? Positive, because y is positive. Right? So what's c? So y equals, in this case, a positive radical. I'm going to write it as 25 minus x squared. What is that? In this case, it's just a semicircle since we only have the positive, but technically, yes, we're dealing with a circle. All right, we have one more example. Let's separate our variables. On the left side, okay, dy over y, so I'm going to write it as 1 over y. And on the right side, okay, because we're going to have to divide this over and multiply dx over. You can write it as dy over y, but I like writing it as 1 over y dy because it's easier to see that that's when I need to use my natural log. Okay, I don't care how you write it, but if you have trouble figuring out, like placing, that that's a natural log, you can write them separately. Okay? So when we integrate both sides, 1 over y dy becomes 1 over x squared. What's the exponent? What's the exponent? What's the exponent on this? Negative 2. This is x to the negative 2. What happens when we integrate? We do what with the power? You add 1. And divide by that power. Yeah, gotta be careful. Okay? Alright, and I only put plus c on one side. Everyone's okay with that, right? Okay. Now what do you want to do? take both sides and make them exponents of e. E to the natural log goes away, and we have the absolute value of y equals, technically this is e to the negative 1 over x times e to the c. Do you agree? All right. Now, that constant will take care of whether this is plus or minus. Technically, when we have an absolute value, we have plus or minus, okay? But that constant will tell us whether our value is positive or negative. All right, so that is our general solution. What we need now is to use our initial condition of 1, 3. So when x is 1, y is 3. C is not equal to 3. Well, it's going to be a little bit over negative 1-ish, but can't we write it as, okay, if we divide e to the negative 1 over, we would have 3 over e to the negative 1, but we don't leave negative powers in the denominator, so 3e. Okay, this is e to the negative first power, right? Which is the same thing as 1 over e. So to solve for c, I multiplied it over. Okay. So now let's go back to our general solution. We have y equals 3e to the first times e to the negative 1 over x. You are not going to leave this with an e times an e. What do we do with those exponents? We add them together. So 1 plus negative 1 over x. But we need common denominators. So we're going to think of this as what? X over x. These differential equations are easy when you don't have to divide y over. If you get to multiply y over to the other side, it makes it a little nicer. But when you have to divide y over, especially with the singular y or the linear y, then you're dealing with the natural log and it takes a little bit more work. Okay? Now, you remember yesterday how I was saying not all of them are solvable? I think you had one yesterday that was dy dx equals x minus y. Can you separate those? We can't separate these. And so this is one that we would have to solve for. Here's your homework. You have a good 8 minutes to get started. When we did the problem of the day, was it easy to read the questions on your phone? Yeah? Okay. Did you like it? Okay.